Before we proceed into the simulation's role in healthcare industry, we can take a look at it, what simulation is, again, very briefly, to have a better understanding of why simulation is a great tool when it comes to in-depth analysis. When we look at different processes, no matter where they are, but especially in industries like healthcare, where there are many interdependent processes going on, dynamic processes going on at the same time, simulation has considerable advantages over the other analytical tools. It's shown very simplistic, in a simplistic way in this graph. You can see that simulation not only captures the randomness in these processes, but also the interdependencies between the processes. It gives you the ability to look at a system without disturbing the actual system, or even before it's implemented in the design process. It builds confidence in the process of decision making, during the process of decision making, because you already know what the consequences of your decisions are going to be. It can look at performance metrics, whatever they are, they're customizable, that are specific to your group or your clinic or your hospital, whatever we want to look at, because basically we replicate the system as it takes, or the end processes as they take place in real life in a computer simulation environment, and run any type of analysis that we are interested in. And as a bonus, the animation that can accompany the simulation that's running in the background gives you the opportunity to look at things visually. If you have bottlenecks, if something is not going right, you can easily spot those, and it's a great discussion starter, enabler in large meetings, especially higher when you are presenting results to high-level executives. Here we have the simplified version of how a simulation process goes. Basically, obviously with any type of analytical study, it starts with describing and understanding what the objective is, and then understand how the process takes place, then build the model. Verification is basically making sure that the model is error-free and working correctly, and then validation is basically, again, making sure that the model that we built is the exact replica of the model or the process that we are studying. And then the real work begins, which is to experiment using this model that we have just built. Try different things, understand the dependencies between different variables, and run many what-if scenarios to understand what the best combination is to get the desired result. And then, based on these, conclude with recommendation as what the best way of going forward is. So simulation is a result of this. Going through this process alone, it makes everybody that's involved in the process understand what is being studied in great clarity. So if there are any issues that wasn't brought up to the table, or it wasn't paid attention to during the simulation process, where including the pre-processes that take place before getting to the model building part, it puts everything on the table. Everybody needs to understand what the process is in depth, so that they can basically study it in a computer model. Again, it gives you the opportunity to analyze many sensitivity analysis at once, at low cost or no cost, and at no risk, because basically you're not doing anything with the real system itself. And then it builds confidence in the decision-making process going forward, because once again, you already know what the results are going to be. And most importantly, I guess, and bottom line for everyone is the assurance of allocation of investment dollars. Making sure that they are invested wisely. We're not getting equipment that we don't need or hiring people that are not necessary. Basically, match the resources with the expected demand. And when it comes to simulation, there are very many tools out there, and each of them has their advantages, and each of them are better used in some certain areas. So PMC has many of these tools in its arsenal. Many experts that are familiar or more than familiar, experts at using many of these tools at once. And because we are tool independent, we don't pick one tool and try to apply it to all the projects we get. We match the tool that's necessary to do the best job we can for the specific project. So when it comes to healthcare, I guess most of the time the questions that we are trying to answer can be combined in one list. What are the efficiencies in the system if we are studying an existing system or even a proposed one? Sorry. What is it that we can do to increase the efficiency or utilization or patient throughput? What gives us the most bang? What is it that we should look at first if you're going to choose, 1 out of 3 things or 3 out of 5 things? What are the things that we should invest in? How do we maximize space utilization and patient flows? Considering travel times, patient conveniences. What is it that we need to be doing when it comes to design changes? And if we have more than one design, in 95% of the time we do, then how do we decide which one is best? Is it best to go with a gut feeling, or is it obviously better to go with quantifying the differences between designs and then basically again choose the right one out of the alternatives? And of course, when we are doing this, we take into physical capacity into consideration, resources, and demand levels. So I'm going to go through some of the case studies briefly, and then we'll look at one in greater detail. And almost in all of them, again, the issues are the same. The things that we are trying to address are the same. So operating room capacity analysis for a newly proposed OR. For expected demand level, what kind of investments should they be making? What kind of how many ORs do they need to have in operation? How many X-ray machines, portable X-ray machines that needed? What are the type of resources that are needed, and how many of them? Are the type of questions we address with this study. Patient registration system, and similarly, how many FTEs would they need, and based on the FTEs that are working, what are the waiting times associated for patients? What system works best? In this case, after some trial and errors, or looking at results, the combination of 2 systems were recommended. Emergency departments are great because there are all these uncertainties associated with them in terms of volume or ESI levels as different types of patients coming in, resources, how do you allocate staff, how many rooms would you need, and what are the costs associated with certain decisions. So these are all addressable through simulation studies, which we have demonstrated in this project. And the one that I want to get into detail is looking at a medical clinic facility. So there was an existing medical clinic, and their question was like, how can we make things better? And also, if you wanted to move to a different building, that, or if you wanted to design a different clinic for ourselves, what would be the best layout be? Of course, this is in partnership with architects. Excuse me. So going back to how a simulation study is conducted, this is basically how we did things. Starting with the analysis of the current data, what the client has, and looking at things and deciding what to use. So we were studying the volumes to see what month or what day of what month we should be targeting as a design day volume in terms of patients coming in. How are the patients being scheduled, or how are they arriving? What are their arrival patterns, arrival earliness, or what % of the time they are late? What are the process flow charts? What's the process that each patient type goes through? What are the percentages? What activities do they go through? They come in as a new patient who might end up visiting lab and X-rays or radiology, versus an established patient who is there to follow up on a certain case, and that might spend a lot less time in the clinic than a new patient. So we just studying these brings up a lot of discussions that are, even at this point, as early as at this stage in the project, that are very helpful to clients. Processing times, either through data collection efforts, or from the data that's available from the client, or just sitting around with the client experts, staffs at these departments and asking them questions as to what they think the most likely duration for an X-ray is, for a CT is, and putting on some distributions again after discussing with them, because as I mentioned earlier, we're not looking at things that are deterministic in simulation. What we're trying to capture is the minimum and the maximum of the process also, because no two X-rays, or I shouldn't say none, but most of the time one process doesn't take only a custom rate. Some of the time we can do something in 3 minutes, where in other times it might take as long as 15 minutes. And the power of simulation is that we are able to capture these through the use of statistical distributions, not just averages. Excuse me. So after we put all these assumptions together that needed to be fed into the model and building the model for the as-is case, we started looking at the base case results. And here are some examples from the base case study. Because we now have the exact replication of the system as it is in real life in a computer environment, we are able to test different things. What happens 10 years from now, when the volume grows by 20%, etc. Or what happens if number of physicians in the system go from 35 to 55 or 65, whatever the projections are. And these are minor sensitivities when it comes to looking different things after the model is built. So in this case, we're looking to see how many patients are in the clinic throughout the day, what are the physicians, how are their times are spent, how their times are spent. When we say physician-patient FaceTime, this is the time the physician has throughout the day, and versus the time that they spend in an exam room with the patient, because they have other tasks that they need to attend to. we shied away from calling it a utilization. Again, for the exam rooms, the same thing. Whenever there is a patient in the room, exam room in use percentage. And of course, these percentages, the variation in those, and also for physicians, these are operationally driven as well, based on how are the patients distributed to the rooms. Is it in a round-robin fashion, or are they assigned a certain room? Even is it predetermined when they come into the clinic? Do we already know what room they're going to go to, etc.? So in this case, in the base case, as a background, the physicians had assigned rooms to them. One physician had 2 exam rooms, and it was the same room all the time. We can look at the time spent in clinic, depending on patient activity, new patients versus established patients, and what they did when they were in the clinic. What is the time that they spent. So after looking at these examples, results, the next step was, well, if you wanted to design something, design a new building for this particular clinic, what kind of clinic would we need to design to get the savings that you would want to get, basically optimize the savings without sacrificing patient service standards. What is it that we need to do? What works best? What gives us the most utilization out of the physicians or nurses or examiners? And we came up with this matrix that had several options in it. What if we don't assign one physician to 2 exam rooms, but we assign one physician to or 2 physicians to 3 rooms, or 3 physicians to 5 rooms? And what if these rooms were not deterministic? What if this was you go to a room wherever there is an opportunity, or whenever the room is available? Physician A doesn't have to go to rooms A and B, but it can go to any room that's available at the time. So of course, as we were looking at this, different needs came up as in triage rooms. We want to minimize the time that patients spend in the rooms waiting. Therefore, we go through a triage process first, these specialized rooms only for triage purposes, and then they are taken to exam rooms. Looking at all these and deciding or investigating to see what works best. And of course, having this many scenarios, it's not very feasible to ask the architect to design several different floor plans for full clinic. So what we decided to do was, because the the architects already had this module concept in their minds, we said, okay, then let's just look at it on a module level for each of these sensitivities, and then once we decide what works best on the module level, then we apply that to the full clinic layout. And this is what the first table is showing. So if you wanted to look at things as they are right now for comparison purposes, then we said, okay, 1 physician to 2 rooms, so we'll model 10 physicians to 20 exam rooms. If you wanted to go 5 doctors to 7 rooms, then okay, we'll do 10 physicians, we'll double the numbers, 14 exam rooms, and we'll need some triage rooms also, and we'll have 5 triage rooms. So these are the scenarios that we we modeled, and after building these for each of the individual scenarios, building the models, then we started looking at results. The second table shows the results when it comes to physician-patient face time percentages, exam room in use. So I have a graph of that chart here when it comes to exams in the room. So when you look at it in the table, it seems like scenario 1 is the best alternative because it provides a high patient-physician face time percentage and also the highest exam room in use percentage. So that's highlighted on the first chart right here. However, again, the advantage of simulation is the ability to look at things in great detail. So when we break this percentage down to see, how that time is spent. Okay, well, exam room was being utilized one way, but who was in the exam room and what were they doing? So we can look at it in 4 different categories. One is the blue one is room reserved, meaning that patient is at the registration, they're filling out the paperwork, they are done with the paperwork. Now it's a matter of having a nurse bring the patient into the room. So the room is waiting. We know the patient, we know the room, so they're matched. They're just waiting. The room is waiting for the patient to get to the room, and then total time spent. The red one is total time spent without the doctor. So the nurse might take the patient into the room, but now after the initial charting is done, now the patient needs to wait for the doctor to become available, and so that the exam can start. The green one is the time spent with the doctor, and the last one is room cleaning after the patient is done. So when we look at this higher resolution, then what we find out is actually scenario number 6 is the best bet because it gives us the most billable time for physician. The physicians are in the room most of the time in scenario 1. I shouldn't say most, but significant amount of the time is spent with the patient in the room. However, with nothing productive going on, the patient is just waiting for the physician. Again, this has to do with how many physicians are attending to how many rooms, whether it's dedicated or not. So the patient could be in the room waiting for the physician to be done in another room, and that drives these percentages. So when we look at patient throughput patient throughput per room or per physician per day, again we see that scenario number 6 provides the highest patient throughput per room per day. When we are making these comparisons, maybe I should have clarified that at the beginning, but because we're trying to understand the limits of the system, what we were doing was to try to push as many patients as possible through the system. So we're not testing one schedule. We don't want the schedule to be the differentiator, but we're just looking at we're doing a capacity analysis right now. So everything is the same, and we're trying to understand which one is able to produce more, which one gives us most patient throughput, and looking at other things also. So the difference, we know that the difference is not coming from anything else but the system itself. Again, as we can see here, it's just a chart of these numbers here. And then once we decided, as we looked at different things with sensitivity, we looked at also the triage rooms that were assigned for each of these scenarios. So basically trying to understand, well, we have 3 triage rooms per module in this scenario, but did we overestimate or underestimate? When we look at the chart, we can see that our average utilization across all the triage rooms are 72%, and the maximum goes up to 80%. So we know that we have a good number picked in terms of number of triage rooms needed for that module, for that scenario. Looking at restroom utilizations, these restrooms are used when a new patient comes in for specimen collection and etc. And then what we were able to demonstrate is actually you don't need this many exam rooms given under the assumptions that we had. So once we picked scenario number 6, we went back to the architects and said, could you please apply this concept to entire clinic floor, and they did, and we want to check and see that we were right to assume that under the assumption of if it works this way on the modular level, then it should work as the same way at the clinic level also. So on this final design analysis, we have that scenario number 6 applied to the entire floor, and we have the projected demand from the clinic, and we look at final design results again. So similar to the very first one, we check to see how many patients are in clinic at different times throughout the day, how many people are in the waiting room, how are our utilizations. These utilizations or in use percentages are different from the first ones. They are not as uniform as they needed to be, or I shouldn't say they needed to be, but they were. And the reason is, again, completely from the operational assumptions. We don't. With the first one, we had more of a round robin, where we start with physician 1 and room 1, and then go around until we come back to physician 1 again. On this one, because of the triage rooms, we need to change our approach. So the round robin approach is more on a modular concept on this one. So you can see that the lower numbered rooms in each module is more utilized, and as you go higher in the numbers, there's less utilization, and as you go higher in the number of exam rooms, the utilization gets less and less, and that's because this facility, as we did it, was obviously over-designed for the expected volume of patients, which is, again, very easy to control, because all you have to do with the simulation model, go back and dial back the number of exam rooms that are available or resources, and basically find that point where you exactly match, in terms of resources, you match what resources you need with the patient volume expected, and basically provide that as a result to the customer, the exact number of resources for each type of resource that lets you meet the criteria that you set for your patients for the given demand. Again, on this first one, as I mentioned before, we wanted to make sure that the overall clinic design results match what we had gotten in terms of modular design, and we were happy that it did match closely. We looked at triage rooms and different triage rooms in different modules at different, similar to exam rooms, decreasing utilization. So we looked at in every, some of the things that we looked at are, I didn't even like check-in queues, check-out queues, basically any process exists in the system, we are able to get any type of statistical information we need out of it, including queues, waiting times, etc. So the bottom line for this project was, after looking at everything and optimizing the design with architects, we were able to reduce the square footage needed per physician by 35%, which in return translated to reducing the gross rent per physician by 37%, and this while bringing up the throughput capacity per exam room by almost 56%. So everybody was happy. We had a design, we knew that worked, and we knew how it worked. So we were architects were happy because they knew what they designed would be the best design for the client. The client was happy because now the question was not, will it work or not, or is it the best design? They had proof that it worked and they knew what to expect out of it. And we were, of course, happy. We were able to help.